Hello everyone, I'm Sathwik Panicker from IIM Rohtak and I'm a first year student. As part of To IPM's initiative, I'm here to give you the right insight about the chapter sequencing series, insight enough to help you solve the questions that usually come for this entrance exam. And firstly, IPMAT is of three divisions, you can say. IIM Indore, Rohtak and IPMAT. For Rohtak and IPMAT, if you look at the questions, you see that the questions are basic as far as this chapter is concerned. Sequence and series questions are usually revolving around the formulas a plus n minus 1 multiplied by d and n by 2 multiplied by 2a plus n minus 1 into d. These two formulae, you just have to substitute the values and you get the answers. But for IPMAT Indore, the complexity obviously is higher, and hence we need a lot more extra concepts. And usually in this time when pressure kicks in and you have limited time, you need to know some kind of tips and tricks as well to approach questions as well as solve questions. And that's why I am here. And without any further waste of time, let's get started. Okay, you can call this as part of my teaching experience. This is me.
Let's see them.
Sequence and series. Coming to the basic theory. The chapter is divided into 4 parts: AP, GP, HP, and special series. Coming to AP, we've all learned this in class 10th. It is a series with a common difference. Take the example 2, 4, 6, 8, 10. So what happens here is, if you add the common difference, in this case 2, to the first element, you get the second element. So in order to get the next element, or in order to get an element in an AP, you have to add the preceding element with the common difference. And obviously we have famous formulae: Tn is equal to a plus n minus 1 into d, and Sn is equal to n by 2 multiplied by 2a plus n minus 1 into d for finding the nth term and sum of n terms respectively. And I presume everybody has learned this particular two equations now. Geometric progressions. If you've not taken mathematics in your class 11th, you might feel a little bit confused here. What exactly is GP? Instead of having a common difference in the case of AP, we are having a common factor or common ratio. So earlier we added the common difference to the preceding number to get the next term, right? Here we're going to multiply it. In this case, 2, 4, 8, 16, 32. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 into 2, 16. 16 into 2, 32. That's how we get the series. It goes on and on and on. Now we have the equations for finding the nth term as well as sum of n terms. Tn is equal to AR raised to n minus 1. So where A is the first term of the GP, R is the common ratio, n is the number of terms. And we also have formula for finding the sum of n terms, A multiplied by R raised to n minus 1. You'll find that there are two equations. This is for two different cases. The first case when R is greater than 1. The other one is when R is less than 1. Okay? And another sub point of GP, something that all the question setters love the most, would be this one particular formula, A by 1 minus R. This is for finding the sum of infinite GP. That is, for example, and also one important thing is R must be less than 1 in this case. Let's take an example: 8, 4, 2, 1, half, etc. So here the common ratio is 4 by 8 or 2 by 4 or 1 by 2. Here R is less than 1. And if I'm asked to find the sum of infinite number of terms of this particular series, I have the formula A by 1 minus R with me. So here 8 is 8, 1 minus R is 1 by 2. So 8 by 1 by 2, which is 16. That's infinite series, infinite GP series for you. Let's get to the next point, HP. Easy way to explain this topic, okay? The easy way is using these examples. I want you to find the reciprocal of each and every term of this particular example. First one, reciprocal of half is 2. 1 by 4 is 4. 6, 8, that. What is this series? It is an AP. So basically HP is a series of reciprocals of numbers or elements in an AP. Special series. Now coming to the next point, special series. Here we have three formulae to find the sum of n natural numbers, sum of the squares of n natural numbers, and sum of the cubes of the first n natural numbers. That is 1 plus 2 plus 3. This is the first case. 1 square plus 2 square plus 3 square. Being explained in the second case, 1 cube plus 2 cube plus 3 cube, the third. You can even try this one out. For example, 1 plus 2 plus 3, the first three natural numbers. That would be 1 plus 2 plus 3 is 6. Let me use this formula. N multiplied by n plus 1 by 2, you'll get 3 multiplied by 4 by 2, right? N is 3 in this case, which is 6. I hope you got the points clear, right? Fine. So the topic is sequence and series, but we've still not defined or we've still not distinguished between these two, right? So the first question, we have a set of 20 questions in this video. We'll be covering them, and each of these 20 questions will give you an idea about one particular concept in this chapter. And some of the questions are typically numerical, and they not just covers the concept, but also are frequently recurring questions in IPMAT CAT or PB entrance exams. So these problems have occurred, have come up in the papers. In fact, the last two questions that I'll be discussing in the video, or maybe in the next video, depends on how much time I take to finish this, have come up in the last year's IPMAT Indore paper. So that we'll have enough practice. And then we'll also have furthermore questions, because this is one chapter where you need enough practice, a lot of practice. And let's get to this question. Difference between sequence and series, easy. I'll give you the most simplest explanation possible. 1, 2, 3, 4. 1 plus 2 plus 3 plus 4. What's the difference here? Here we're using the symbol plus. Here we're using the symbol comma. That's it. This is a sequence. Ignore the terrible handwriting. This is a series. So series is a sum of the terms of a sequence. That's all there is to it. I hope I made myself clear. Question number 2. It says the third term of an AP is 6. So A3, right? A3 is 6. A6 is 30. What next? All the terms of the AP are multiplied by 5. What is the 10th element of the series, of the new series? Okay. Let's take an example. This question will be covering the first subtopic of AP, you could say, first concept under the division AP. I'll give you an example to explain the concept. So here, all the elements of this AP have been multiplied by a constant, 5, right? So let's take an example of an AP, 1, 2, 3, 4, 5, the most basic one. And multiplying it by 5, what's the observation that you can make? Is this series having a common difference? Look at the difference. 10 minus 5 is 5, 15 minus 10 is 5. So one thing is, this is an AP. Great. Another observation is that the common difference here is 5 times the common difference of the original series. 5t, or you can say t2 is 5t1. Now, similar to that, we also have a concept for GP as well. That is, let's take a GP again, 1, 2, 4, 8, and we are going to multiply this by a constant. Let's see, we'll multiply it by 2. So 2, 4, 8, 16. What's the observation? Observation that this is a GP. At the same time, the common ratio is a constant. It's It is the same as the original series. I hope I made myself clear again. If there are any doubts, please make sure that you cover it one more time, you watch it one more time, or maybe slow down the speed or whatever. Don't leave any doubts unturned. Make sure if you have any genuine doubts, you can put it in the comment box. We'll definitely answer that. Now, so this is the concept that revolves around this particular question. Let's get back to the question. A3 is 6 and A6 is 30, right? अच्छा. अब क्या करना है कि we have to multiply all the elements by 5 and we'll get a new series. We've got to find the 10th term of the series. So I'll be describing each element of the new AP with capital letters. Okay, so let's first work out with what we've got. That is A plus 2D is 6. We all know the nth term formula, right? If you don't know, just recap it. Take the difference between equation 2 and 1, get 24, D is 8. Great. Now what would be capital D? It will be 5 times of 8 since all the elements have been multiplied by 5. 40. Now we also have to find small letter a. We just have to equate D is equal to 8 in any one of these equations. So A plus 16 is equal to 6. A is equal to minus 10. And capital A would be 5 times of minus 10, which is minus 50. Okay, great. Minus 50. Now we've got to find A10. A10 is A plus 9D. That is minus 50 plus 9 multiplied by 40. Na? So we'll get 310. Simple. That's it. We've solved question number 2. Question number 3. Again, another concept. So when we are asked to actually give 3 terms of an AP or decide 3 terms of an AP or 4 or 5 terms, we have some basic rules. So if we want 3 terms of an AP, we have we can assign term 1 as A minus D, term 2 is A, and term 3 is A plus D. Similarly, if we want 4 parts or 4 terms, it's going to be A minus 3D, A minus D, A plus D. So the basic principle for considering these notations is because we have to simplify our calculation. So if we add these 3, let's say, if we add these 3, D gets cancelled and we'll end up getting 3A. That's the basic crux of why we're using this. And for 5 terms, we have A minus 2D, A minus D, A plus D, and A plus 2D. Great. So this is a theory that will be coming under this question. And let's read the question. I'm supposed to read it first, of course. Either way, it doesn't really matter, right? A number 20 is divided into 4 parts that are in AP. So we need 4 terms of an AP. And the sum of the 4 terms would be 20. So let's say A1 plus, A2 plus, A3 plus. You know what? I'll clear this. And A1 plus A2 plus A3 plus A4 is equal to 20. Now we can replace that with the concept that we now learned. If we need 4 terms, we can donate and denote them as the numbers and the words that come from my mouth instead of donate comes. Great. Either way, 20. Cancel all of them. We'll get 4A is equal to 20. A is equal to 5. Great. 5. And product of the first and the fourth is to the product of the second and third is 2:3. Okay. So we'll clear this because we might be running out of space. A is equal to 5. keep that there, and 2 by 3 is equal to product of the first. The first term was a minus 3d, if you remember. I think you should jot down whatever I'm writing so that you will also be actively participating, right? A minus 3d, and fourth term, that is a plus 3d, by a minus d multiplied by a plus d. Now a square minus 9d square a plus b into a minus b, right? D square, oh, writing is getting worse. 2 by 3. What else do we have? We cross multiply, right? 3a square minus 27d square by 2a square minus 2d square is equal to, these two are equal. Fine. Now we can bring a square over there, so you'll get a square is equal to 25d square, or a is equal to 5 root d. And we know a is equal to 5, so root d is equal to 1 or d is equal to 1. Awesome. Let's clear. So a is equal to 5, d is equal to 1. We need to find the largest part, that is a4. So a plus 3d. Remember, a plus 3d, right? Yeah. 5 plus 3, 8. Great. Yes, we've solved question number 3 as well. If the average of the third term and 18th term of an AP is equal to the average of the entire AP, find the total number of terms in the AP. So for answering this question, you again need an extra concept, and I have a concept booster for you. The concept of corresponding terms. Let's take this AP. I'll explain what corresponding terms are. Let's take this AP 2, 4, 6, 8, 10, 12. Take the first and last term of the AP, 2 and 12, and find the average. 2 plus 12 by 2 is 7. Take the second last and second terms. You will get 7 again. That is 10 plus 4 by 2 is 7. Right? 12 plus 2 by 2 is 7. 6 plus 8 by 2 is 7. You might ask, what if there are odd number of terms? Then what happens is the average would be the middle term. For example, let's take 1, 2, 3, 4, 5. 5 terms, odd number of terms, right? So the average would be 1 plus 5 by 2 is 3. 2 plus 4 by 2 is 3. Middle term is 3. Awesome. And another observation is, let's take the total average as well. 2 plus 4 plus 6 plus 8 plus 10 plus 12 by 6. What will that be? 6, 12, 20, 30, 42 by 6, which is 7. So the average of the corresponding terms would be the average of the total AP. These are corresponding terms. Now, another interesting property of these corresponding terms is that, let's take this AP itself. So A1 and 3, 6, A6 are corresponding terms. A2 and A5 are corresponding terms. A3 and A4 are corresponding terms, right? Now, if you take the sum of these two, 1 plus 6 is equal to 7. Okay, it has nothing to do with the mean. 2 plus 5 is equal to 7. 3 plus 4 is equal to 7. Does not have anything to do with the mean, but it has something else to do with n plus 1. What is n? Total number of terms. And here is 6. 6 terms, right? So A3 plus A4, or the third and fourth term, would be corresponding terms if there are 6 terms in the AP. I hope you got the points. Right. Now, with this in mind, let's get to the previous question. Let's see what was that about. If the average of the third term and 18th term of an AP is equal to the average of the entire AP, find the total number of terms in the AP. So this is basically the definition for corresponding terms, right? Average of the third term and 18th term is equal to average of the entire AP. So what we can conclude is 18th, third and 18th terms are corresponding terms. So how many terms are there? 3 plus. So what was the specialty? If you take the sum of 3 and 18, you'll get n plus 1 terms. So n here is 20. That's it. Next, again based on the same concept. In an AP with 19 members, the average of the second and 18 members is equal to 34. Find the 10th term. This is like the other way around the previous question. So second and 18th member terms, right? And there are 19 members. So as you can see, 2 plus 18 minus 1. So it works. So 2 and 18 are corresponding terms of an AP. So what is the specialty of corresponding terms? Before that, let's read the question again. The average of the second and 18th members is equal to 34. Find the 10th term. So 19 members. 19 is odd. And I'm sorry for that. 19 is odd. What was the specialty when there are odd number of terms? The middle term would be the average. So the average of corresponding terms will be equal to the 10th term, right? So the 10th term would be 34. Easy. If you have any doubt, rewatch the video or drop your doubts in the comment section. We are ready to answer you. Good. Next. Another question, sum to 12 terms of an AP is equal to sum of 18 terms. What will be the sum to 30 terms for this series? So S12 is equal to S18. We need to find S30. Let's see if there is a concept booster. Yes, there is. Okay, theory time, the special case of... So what is special about this question? S12 is equal to S18, or sum to N1 terms of an AP is equal to sum to N2 terms of an AP. 12 and 18 here in this question. So let's take these three series. Firstly, series 1, minus 12, minus 8, minus 4, 0, 4, 8, 12. Now, if you look at it, you'll see that S2 and S5 are equal. Let's see. Minus 12 minus 8 is minus 20, right? I'll do some annotation as well. S2, right? S2 is minus 20. And let's find S5 as well. It's not 55, it's S5. Minus 20, minus 24, minus 24, minus 20, 12. This is S5, sorry. Minus 24, minus 20. So here, S2 is equal to S5. Similarly, if you take S3 and S4 too, you'll get both of them are equal. You'll get that both of them are equal. So some of the terms, let's see what the note is. Some of the term numbers which exhibit equal sums is constant for a given AP. Before getting into all that, let's see when these kind of cases occurring. One common point is, let's see if series 2 also has a similar idea. If you look at it, if you closely analyze each and every sum, you'll find that this case is not followed in series 2, but it is followed in series 1, and it also happens for series 3. Now, what are the common properties of series 1 and series 3? They've achieved this case, right? This particular property. What is common between these two? You can see that they start with a negative number if they are increasing, and I've not mentioned a case when a decreasing AP happens. If a decreasing AP, or if D is a negative number, the first term has to be positive. If it is an increasing AP, in the case here, D is 4, right? It is positive. So the starting term would be a negative number. Keep that in mind. And other than that, they should cancel each other. For example, minus 12 and 12 are cancelling, minus 8 and 8 are cancelling. That is a problem with series 2. None of it cancels each other. Minus 8, there is no corresponding additive inverse for that. And because of that, series 2 does not qualify. On the other hand, series 1 and 3, they qualify pretty well. Now, one interesting property about these two series is that the sum of the term numbers which exhibit equal sums is constant. Like I mentioned before, S2 is equal to S5 for series 1, not 55. S3 is equal to S4. Take the sum of these two. 2 plus 5, 7. 3 plus 4, 7. I have something to do with 7, I think. Last question also had 7 occurring a lot of times, right? Not Ronaldo fan. S2 is equal to S5. So 2 plus 5, 7. 3 plus 4 is equal to 7. Now, that is a constant. And we'll be using this idea to find the answer for the question that came before. Alright? Let's see. Sum to 12 terms of an AP is equal to sum of 18 terms. So it is the case that I mentioned before. What will be the sum to 18 terms for the series? Fine. Awesome. S12 is equal to S18. So what happens here is, if you take this sum, they have to be constant, and that happens for every element. So that means S11 is equal to S19, S10 is equal to S20. Similarly, S0 is equal to S30. And if you know, and all of you might know, right? There is no concept called zero term, or you can say sum of zero terms of an AP is obviously 0. So S30 is equal to 0. That's it. Awesome.